Hello everybody, good night. We meet again. So back to the value at risk, where value at risk consists of three important elements: time horizon, confidence level, and the capital of or the invested capital. Okay? So the VAR basically value at risk provide a quantitative values to show us what might be the worst loss in let's say 1 day or under let's say 99% confidence or 95% confidence level. Okay, so now we're going to further a bit about if let's say for the past 100 days, so I'm going to have the price or the returns series of my let's say the past, let's say for the past 100 days. Okay? So this is my returns record. Okay, returns record. So let's say mostly of your returns is close to zero, and then there are some is let's say -6 or -7%, and there are some days within 100 days or 3 months. Sorry, this trading days should be more. Okay? Let's say 4 months. You might have some very good returns, okay, over the 100 days. Okay, so based on this, most probably we have a symmetrical distribution. Okay, so if now we have a distribution to represent our returns over the 100 days, then most probably we can just say that the appropriate distribution can be used, should be symmetry. So this is the common characteristics of the returns. It should be symmetric, and then what else? It should be the bell curve or bell shape, and then yeah. So with these two characteristics, the common distribution we can think of is the normal distribution. Of course, there are some others heavy tail distribution like students T distribution, and some other distribution. Okay, so this might be the very common distribution used in the finance. I think the student T might be a more appropriate one. So we discuss this afterwards. Okay, so if you're talking about a 95% confidence, so basically, if you want to measure the worst loss, let's say you have a long position of a particular asset. This can be stock market, it can be options or futures or any other derivatives investment or instrument. So the long position means you own the asset. Of course, you hope that the asset will appreciate. Therefore, by selling it, you're going to have the profits with the price difference. So we are talking about this area only. So any of this value less than the VAR will be considered, the quantile involved are in percentage. So if you're 95% confidence, means that you're focused on let's say this is a long position. Long position. Long position means you own the asset and you hope you will appreciate. So long position means you will focus or focusing on the worst 5%. Okay, so this actually referring to the tail of the left tail. So if long position, most will be your focus on this 5% worst returns. So this is the return series over the 100 days. So VAR is the return level. So this is a return. Okay? So the VAR basically, so it should be a negative value. Okay? Negative means what? The loss. Okay? The loss. Okay? This will be the loss. So there will be only 5% chance your return will be worse than this, isn't it? Okay, so if you have invested, let's say, if you have invested, let's say 100,000 K, okay, if you invested 100,000 K, let's say in dollar, so the 5%, 5% VAR, the 5% VAR you expect to lose, you expect to lose more than 5%. So 5% means $5,000. Okay, so this one is only how many? Is only 5% of all the cases, all the all the historical data. Okay, so this is, if you think of now a series of returns, then you can view it in this particular way. Okay, so first of all, the formula you can use under the assumption. So assumption, let's say your returns is normally distributed. Okay, normally distributed. So in this case, we can use the formula VAR, which is the mean of the returns plus the Z sigma. Okay, so this is something related to the normalization of the Z value. Okay, we have Z value, you have X minus the mu over sigma. So if X is the returns, so the value at risk actually is the returns level. So X, if you refer to VAR, then this will be mu plus Z sigma. Okay, so this will represent this value. Okay, so for the definition, we have the mu, which is the mean return or long-term returns. Okay, mean return. So most probably because the is symmetrical distributed, that means most probably the value will close to 0. Okay, so this one most probably will be close to 0. So for the sigma representing the market volatility or the returns volatility, okay, so this is returns volatility, which is the standard deviation. Okay, and then Z score basically is the normal values. Okay, normal values where you can just check at the normal table. So this is a normal table which provide the cumulative distribution as in the Z value, indicating the probability less than or equivalent to Z. Okay. Okay. So this is the Z value. So this is the Z score. Z score for with the specific confidence level. So for 5%, 95%, the Z value is 1.645. Okay, so this is just get it from statistical table. Okay, statistical table. So based on this formula, we can actually try to calculate the, let's say, a 1-day VAR at 95% confidence for a long position investment of 100K, let's say. Okay. So the assumption, of course, let's say the daily return, the mean is 0. Let's say the volatility, daily volatility is, let's say, 2%. Okay. So 2% means 0.02. So the confidence level, 95%. And then the invested value, 100K. Okay, 100K. So from the table, obviously, step 1 is Z 0.05 is negative 1.645. Okay? So this is actually referring to this particular value. So what is this Z value? So this is basically equivalent to minus, okay? Because you are concentrated on the left tail, okay, of the distribution. So 5% the lowest returns, 5% lowest return. So secondly, we can calculate the VAR. So VAR basically is the capital times the amount of value. Okay? Or sometimes you can say this is a quanta. Okay? So the capital, let's say 100K times the mu minus Z sigma, isn't it? So this is 100K. So this is 0. Z is 1.645. Sigma is 0.022%. So in the end, you will get around minus $3,090. The negative mean is a loss. Okay? Negative mean is a loss. So the risk is a loss. Okay? The risk is a loss. So you can just say that. So there are 95% chance, okay? 97% chance you will not lose. You will not lose more than this amount, right? $3,290 in one day, right? In a single day or in one day. So of course there's another 5% by chance you might lose more than $3,290. Okay. Okay, great. So this is for one day. 95% confidence level, one day. So this is a VAR determination. Okay? So if you extend this to 10 days, okay, this one is 10 days. So we just need a factor of time here, okay, in the square root factor of time to determine the value. Okay. So for 10 days, you need to scale, because we have one day value already. We scale the VAR using the square root of so-called the time rule. Okay, time rule. So for VAR for 10 days, for 10 days VAR, okay? So this is equivalent to 3290 times square root of 10. Okay, so this is a 10 days value. So end up you have 10402.97 dollars. Okay, so this is the amount of money you're going to lose for 10 days. Okay, so this is 10 days VAR. Okay, or this is 10-day 95% confidence interval. So sometimes they say 5% VAR, okay? But this is 10 days, 5% confidence interval. Okay? So what you can make a conclusion is, so there is 95% confidence or chance you will not lose more than, sorry, this is dollars, 10402.97 over the 10 days. Of course, by chance, there's a 5% chance that you might lose more than this. Okay, so this is basically some simple application. If you view the distribution and somehow this distribution is following a normal distribution, then we can use this particular formula to determine the VAR. So this is basically, this is not actually VAR, this is the quanta of VAR. So, okay, this is the quanta. VAR is supposed to be amount times this quanta. Right? So the VAR is the amount of value is Q VAR times the capital. So because VAR is the amount of money, amount of money. Okay? So that is the money you're going to lose, the risk. If 10,000, then VAR is 10,000. Okay, this is a simple example. If you view this return series following a normal distribution, okay, else, of course, if it's following T distribution, then you should use T instead of Z. Okay, so for 10 days, you just need to have a time scale to the square root of time, right, to determine the 10 days ahead forecast prediction. Okay, guys, so that's the end for this particular part. We'll discuss more after this. Bye, guys.